Hey guys, welcome back to another video. Today I'm going to be taking on LeetCode 977 squares of a sorted array. This is as part of my raw and authentic LeetCode walkthroughs playlist, where I go at problems raw and authentic and I just try to solve them without knowing the answer beforehand. So this is an easy problem. Given an integer array nums sorted in non-decreasing order, so the numbers are increasing, return an array of the squares of each number sorted in non-decreasing order. Okay. So one way that so like the first most obvious way to solve it would be to go through each number, square them, and then use one index and go through and square each number and then sort them at the end. So let's code that up. That's actually pretty straightforward. So for I in range, length nums, we will just say, I guess, wait, sorry, I don't actually have to go by index. I can just say for num in nums. Wait, no, I can't say that because I have to update the value. Yeah, okay. For I in range, length nums, I just say nums I equals, what should I just say, times equals nums I. I guess I could just say that. And then just return nums. Let's sort it. Okay, let's see how this runs. Okay, so this is like a pretty, this is like the most obvious way to do it. But I suspect it's probably not the best way, just because we pass through each element here. So this is O of n, and then we sort them, and that in and of itself also adds to the time complexity. So this is probably not that optimal, but I'm gonna give this a submit just to see if this actually works. Okay, it does, and it's not terrible for either of memory or time complexity. But let's see if I think I have another idea for how I could solve this. So another way I could do it is, so let's say we have like a result that's the same length as the output. So since I'm going to be using length nums quite a bit, I'm just going to say n equals to length nums and just store that variable. Okay, now what I'm thinking is we make a result. Okay, the result will be something like this. So it's just going to be a list of zeros. So for instance, right here we have 5 terms. So result is going to look something like, this. So what I'm thinking is, what we should do is, we could just take the largest squared number out of all of this and the smallest actually, and just, it's non-decreasing. Yeah, so it should be increasing. So we could just take the smallest value and no, we want to start from the ends. So what I'm thinking is we have some index that tells us where we're at in result, and what we'll do is we just have to compare the smallest negative number and the largest positive number and the squares of those. So for instance here, pretend we had like -11, right? We'd want 121, which is -11 squared, to be here rather than 10, right? So really all I'm going to do is I'm just going to look at these, I'm going to compare their absolute values, and then I'm going to replace this index, and then I'm going to move this index here, and then whichever one I add, I'm going to move that one's index. So for instance, in this case, I'd compare -4 and 10. The absolute value of -4 is 4, so 10 is greater. So I'm going to square 10, so it would be 100, and I'm going to make this 100, right? This is following along with what they expect in the output, right? Then what I do is I would move this index. This is going to be a pointer to 3. So now we're not really looking at this. Now we're going to compare these two. Now the absolute value of -4 is 4, and the absolute value of 3 is 3. So now we're going to take this and we're going to square this, and we're going to put it at this index now. So that would be 16, and then we'd go from there. So then we'd have 9, and then 1, and then 0, and then that's 9, 1, 0. So that works out quite nicely. So first we need a left pointer, we need a right pointer, so that would be n minus 1, but we also need a position in our result. So I'm just going to call this pos for position, and this should be, result is going to be the same length as nums, so it should also just be n minus 1. So now what I'm going to do is I'm going to run a while loop. So while L is less than or equal to R. Yeah, it should be equal to, right? Because let's think about this. So what would happen is R would come here, then L would come here, then R would come here, and then L would come here. So then L and R would be equal to each other, and we'd still want it to run, so that 0 still gets added. So we'd want this to run still when L and R are equal to each other. But then after that, one of them will be moved. So let's do this. So we'll say, so what we wanted to check is if the absolute value, which of the absolute value is greater. So we'll say if the absolute value of nums L is greater than the absolute value of nums R. This is a built-in function, by the way. So if the absolute value, okay, let's actually do R first, just because I want it to be able to compare easily to the question here. So if R is greater than L, so R is greater than L, then what we're going to do is we're going to take R squared, nums R squared. So we'll say, I guess we could say like next val equals to nums R, and then we'll square it, okay? And then what we're going to do is we're going to say result at pos, and we're just going to add, it equals to the next val that we have, right? So yeah, this value is going to get replaced, and then we move R in, so we decrement R, right? Otherwise, else what's going to happen is L was greater, so then we're going to have basically the same thing here, except it's going to be nums L, and L is going to get incremented. Everything else should remain the same. And then what also happens is, since we're now adding a value to a result, we have to change pos 1 down, so we have to decrement pos. Okay, this makes sense. Now let's try to return our result and see how that looks. Yeah, okay, let's see. Okay, beautiful, awesome, first try, nice. So, I think I explained this like pretty decently, but like essentially, pos is on some index, right? And we compare the ends, because really 3 is not going to be bigger than 10. This is already sorted, right? So really we have to look at the absolute value of the smallest negative versus the largest positive. And if the positive, for instance, is larger, then we put that square in for pos. We move pos down the list, or I guess up the list, and then we get this out of the picture. So we move the pointer to this. So now we're looking at this list, really, and then we're going to do the same thing for this pointer, and then when that -4 gets added, we're gonna take the -4 out of the picture. So now we're looking at this, and we're gonna move our pointer in result, which is pos. We're gonna move it to here, and then we're gonna go from there until the entire list is done. So now let's just see. Let's try to submit and see if this works. Okay, beautiful. So. Okay, let's compare solutions here. Oops. So it looks like the runtime was a bit worse, actually. Interesting. Let's see. Interesting, actually. Let's see the complexity on this one. Yeah, so it's n log n. But this does it in one pass, right? L goes through in one pass. So how come it's... Yeah, because it's just updating the pointers. I'm not entirely certain about that, actually. Yeah, well, I mean, this does make sense to be like the most optimal way because you're doing it in one pass. I'm not entirely sure why. Huh. I feel like this doesn't make sense. This doesn't really check out with like the code. Maybe I'm missing something. Anyways, well, I solved this problem in two ways now, so I'm just gonna leave it there. Um, so that's the end of today's video. If you guys learned something, please let me know down in the comments below. If you guys think that there was like a better way to solve this, because or if you have like an explanation for why this might be worse in time complexity than my first solution, please let me know down in the comments below. I'm just gonna double check that I looked at the right ones. Okay, yeah, okay, yeah. So yeah, if you think you can, like, if you have an explanation for why it's not working, please let me know down in the comments below. Definitely, I will definitely check that out. But besides that, that's the end of today's video. I hope you guys enjoyed, and I hope you guys learned something, and I will see you in the next one. Bye-bye.